Hey everyone, Geek37 back with another video, and this is the fourth video in my series on exploring the heptagonal triangle. And yesterday, in the video I uploaded, I did b squared over a squared plus c squared over b squared plus a squared over c squared equaled the value of 5. Today I'm going to do kind of the opposite of that. I'm going to do a squared over b squared plus b squared over c squared plus c squared over a squared equals some value. Now let's go over again that a, b, and c are the side lengths of the heptagonal triangle in order from least to greatest. A is opposite the angle measurement pi over 7. B is opposite the angle measurement 2 pi over 7. And C is opposite the angle measurement of 4 pi over 7. And those angles are labeled capital A, capital B, and capital C. Now, as you can see off to the right side there, I have listed the Ptolemean identities that I proved earlier in the series, and we are going to use them in a rearranged way in order to prove the value that we're looking for. So as you can see here, where I have a squared right here, I'm going to use this particular identity here that I'm labeling in green in a rearranged fashion. So I'm going to rewrite that as b squared minus ac over b squared plus, now we're going to take b squared here, and I'm going to rearrange that as c squared minus ab all over c squared plus, and as you can see here, the c squared over a squared. I'm going to take the c squared here and rewrite this as a squared plus bc all over a squared. And as you can see right off the bat, I can actually do some reductions. As you can see there, b squared over b squared is 1, c squared over c squared is 1, and a squared over a squared is 1. In order to save some space, I'm going to just write, we will know that each of these is equal to 1, and 1 plus 1 plus 1 is 3. So we're going to write that. And then in order also to save some space as well, let me change this color over to, say, this magenta here. What I'm going to do is we're going to rewrite each of these parts as separate fractions, and you'll see why I'm going to do that here in a moment. So let's do this in the proper order. Let's say I think what I'll do is let's go back to this. Let's erase this, put it in the proper order. So we'll do minus a c over b squared minus ab over c squared plus bc over a squared. Now, using this magenta here, we're actually going to refer to this one right here, and we're going to rearrange it so we're able to cancel off B's, C's, and A's from each fraction. So let's rewrite these in the way that they're supposed to. So we'll rewrite this as minus, so AC here. I'm going to rewrite this as, in parentheses, B C minus AB all over B squared minus, and the AB here, so we're going to rewrite this as BC minus AC all over C squared plus, and now of course BC is equal to AB plus AC all over A squared here. And what can happen is we can factor out A's, B's, and C's from each one here. We can cancel those off. So we're left with B on the bottom, C minus A on top. We can cancel, we got the C here, and we're left with B minus A on top. And here we're left with B plus C over A. So down below here, we've got 3 minus C minus A over B minus B minus A over C plus B plus C over A, just like so there. Now, where do we go from here? What I want to do is I want to rearrange these into separate fractions so we're able to do this right. So we're going to do this. We'll distribute the negative through on each part here. So we'll get minus c over b plus a over b. And then on the next one, we'll get minus b over c plus a over c. And then, of course, we have the plus b plus c over a. So that'll be ba plus c over a. Now on the next line here, what I'm going to do is I'm going to rearrange this into two separate parts. So I'm going to go plus, and in the first set of parentheses, I'm going to write c plus a plus a over b minus b over c. And then in the next set of parentheses, I'm going to write plus b over a plus a over c minus c over b, just like so here. And what we're going to do is we're going to find the values in each set of parentheses by reducing down those fractions and seeing what we're going to get. Now let's do the first part here. And as you can see here in the first part, we have the two fractions. So what we're going to do is we're going to work this out. This will be b plus c, or bc plus a squared over ab minus bc, b over c. And if you remember, we have bc a squared plus bc from yesterday. So let's write this down, make sure we're being consistent going through here. Since we're working this down first, we'll work down the other part here afterwards. So that worked out to be, if I remember right, that worked out to be c squared over ab minus bc. So c squared plus ab, if we remember right, that was b squared plus ab all over ab minus bc. So what happens is we get b squared plus ab. We know for a fact that the ab's cancel off, so we're left with 1 plus, and of course b squared over ab is b over a minus b over c plus b plus a plus ac minus cb. And then from there, we saw that 3 plus 1, that was equal to 4. Well, we're just going to keep that there for a second. Let's see here. This was, when we cross multiply here, we get 1 plus, we get bc minus ab over ac. And then we've got the second part here in parentheses that we will work out here after I'm done with that first part. So what happens is we get bc minus ab, and of course from the identity in pink over here, that works down to be AC. So we get AC over AC plus B over A plus A over C minus C over B. Well, of course, this part works out to be 3 plus 1 plus 1 plus what's left here in the parentheses. Well, of course, 3 plus 1 plus 1, that's 5. Plus A, B, plus BA plus AC minus CB. All right, give me a second to do some cleaning up of my screen and we will finish the video. Okay, so I just erased the left side of the screen here and I just transferred that last line of algebra over. So what we're going to do is we'll continue on with reducing this set of parentheses, cross multiply. we'll get BC plus A squared over AC minus C over B. Now what happens is, and again, like before, we've had A squared plus BC. That will equal C squared over AC minus C over B. And again, remember, A squared plus BC comes from that identity, the third identity that I have marked in green. A squared equals C squared minus BC. So what will happen is we can cancel a C off from here. So we'll get C over A minus C over B. Cross multiply, so we'll get BC minus AC all over AB. Well, from the fourth identity, the one we have marked in pink, we know that BC minus AC will equal AB. So we'll have 5 plus AB over AB, which of course equals 5 plus 1, which equals 6. So I can go up here and say straight up matter-of-factly that A squared over B squared plus B squared over C squared plus C squared over A squared equals 6. And that concludes the lesson right there. Now, the reason I decided to go over this particular identity is that we will need that down the line to prove some trigonometric relation. That's quite important in this series, and it's also a continuation of, and it's an extension of proving the Ptolemaic identities that I proved earlier in the series. So that is why I decided to do this reciprocal case compared to yesterday this early in the series. So I hope you enjoyed this video. I enjoyed making it. This is Geek 37 signing off.